we're going to take the current here while it's off. Current while it's off. Watch when you turn on the thing, it goes quickly to infinity on the current. Changes in this is we have the high voltage ground is unhooked. It's not even being used. The only thing that we have hooked up is the high voltage power lead going into a new setup. These are all in series, but they're stacked in capacitively in parallel. And we got 3 pancake coils stacked. We have,
and real quick, it goes in through the center core.
Yeah.
And then it comes up. We're taking the energy out of the shield of the triple pancake.
Okay.
Coils.
Currently on this setup in low mode, this neon bulb, which lights up at 95 volts when it sees 95 volts, and we got this in low mode, and we have the LEDs bulbs flashing. We have the incandescent in the middle, and this time the incandescent is not really lighting up in low mode.
Go ahead and turn it up.
I'm going to turn it up, and you might see it come on a little bit.
Yeah, so the 4-watt incandescent is barely illuminating.
Over here, this other neon bulb with the voltage down, you can see that it's not lit.
I'm gonna remove this light so it's not.
And I gotta turn the voltage up. You can see that come up. But the key point here is this bulb is just laying on there, and it has the antenna lead going out to the table. That's it. It's not hooked to ground or anything.
90 volts, one wire.
The 95 volts there to light up. Here, when we have the voltage all the way down, and we got the desktop fluorescent bulb hooked to the other end of this bulb, which is picking up 95 volts, and then it goes down. Now I'm going to turn up the high voltage field, and look, it's starting to come on within the field. You can see the desktop bulb lighting up.
Yeah, I'll touch the opposite side here.
And see, Phil, it's become the ground, and it's lighting up. Now I'm going to become the ground on this fluorescent bulb, which doesn't have any wires on it at all. It's within the field. I'm going to provide my body ground on the thing, on the ground leads. And we're going to watch it light up. Isn't that cool? That is so cool. And there's no wires on this. I'm just touching it with my hand. It's lighting up in my hand. This is like a Tesla effect here. Down on the bottom we have like 400 volts going through that cap, which is also in series with this other stuff that's here. It's a 50 volt cap, and it goes down to the toroid coil at the bottom.
One wire.
And it's all just one wire. We unhooked the other wire that we were using before. Here it's just hanging. We're just using one wire going through here. We're using 2 wires on the output, and we're coming into full wave bridge. We have a filter cap here. We got lights that are flashing almost as fast as the ones at the top, and the ground loop that's coming off of the end of this is just looping through, where the other end is just open on this, and these are lighting up a lot faster. And in between we have the current reading, and this is in milliamps, and I can't see any current at all per se, but yet the lights light up.
And it's being measured in between these 2 bulbs.
So I have no clue what's going on there. And that's about all we have to show, but this looks like a real one wire setup here, and the current here is showing infinity because we only got really one wire set up. And we have 400 volts over there showing across the cap. It's a 50 volt cap. It's not blowing up. That's AC voltage. Down here we have this meter in current mode, and we're showing no current, but yet the lights are lighting up. Well, that's about it for this video. And just light up the bulb here again when you're touching. Bright this up a little bit more here. And the other end hooks nowhere. This just hooks to the neon bulb here. That's it. And it's within the field. So this is the effect of this video. And that's it. It's done.